My name is Ilija Vukorep, and I'm from the BTU Cottbus-Senftenberg. There I'm chair for digital design methods. And together with Gregor Zimmermann from GTEx Engineering, we will together present you the paper Robot Controlled Fabrication of Sprayed Concrete Elements as a Cyber Physical System. Here we deal with a very old technique of spraying concrete and joining this together with robotic automatization. At my department, we are also working with and having research with architectural fabrication. And since 2018, we are organizing a symposium that is dealing with AI in architectural fabrication. This year, despite this Corona situation, we are going to invite you, hopefully at autumn and winter, also to this symposium. So maybe we can meet us, see us later this year.
Hello, my name is Gregor Zimmermann. I'm CEO of the company GTEx Engineering, and our research and development company is specialized on the optimization and development of any kind of concrete. Our clients are located all over the world, and we are developing this kind of technology based on their local requirements. But next to that, we are also specialized on the development of concepts for new production methods. So for instance, when we develop a new concrete, it's also essential to have a new technology to produce this new kind of concrete. So in this case, we are talking about ultra high performance concrete that can be used in shotcrete machines to produce really thin exposed concrete facade panels.
During manual concrete spraying tests we made with our students, we figured out, well, this was quite obvious, it's nothing unusual, that spraying is, concrete spraying is a very imprecise way of layering concrete on the area. So usually the area that is being sprayed is quite big. So we asked ourselves, how is it if we want to make smaller modularized elements that we can put next to each other in this spraying technique? And the test showed that this is quite difficult, because the person who's spraying is not doing this quite precisely, just due to the heaviness of the machine and a very quick process that is happening there. So the movement of this person who's doing this is not very precise on the one side, and on the other side we have the problem of measuring exactly the depth of this sprayed layer. So this is something that is also very important to know how much concrete is now covering some specific spot that has been sprayed. So this was the reason why we wanted to start to think about how we can automatize this, how we can do it much more precise.
In this video, we show you our ultra high performance concrete and how we can shotcrete that with a nearly regular shotcrete machine to a vertical wall. The post-production and the post-treatment of the facade or the element is also possible, and you can see the adhesive strength of the material to the vertical wall. And we can use this kind of ultra high performance concrete to make really thin layers of a facade panel. And we can also do a kind of layering where we shotcrete several kind of layers to one sheet of panel. In 2015, we realized our first shotcrete robot. The robot was designed to spray ultra high performance concrete, and the client's idea was to produce flat ventilated facades made out of ultra high performance concrete or three-dimensional platforms for prefab bathrooms. The machine was installed and successfully started to produce the facade elements. What we show you in the next slides are our further developments for this kind of shotcrete machine. To give you an idea how surfaces can look like when we shotcrete them with ultra high performance concrete, you can see these pictures here on this slide. The pictures are showing surfaces for ventilated concrete facades made of UPVC. They are produced by ourselves and by our client in the United States. So the panels are actually flat, but we can use the technology to produce three-dimensional facade elements.
When we observe how these modules are produced, we can see that this is a very decentralized process. So we have this form maker, for example, who's designing some form, and he is passing this data to somebody who's then making a mold out of it. So in the CNC milled part then. And from here, this is then going on to other services. For example, spraying that is then having several other undercomponents. Then we have the post-production, foam removal, then afterwards post-production of parts. Then in the end, it's then placed to the final position. So this is a continuous process where and it's very interesting where, in fact, the amount of data from the first virtual model is increasing quite a lot. So we have adding, for example, of scan results from the milled mold. For example, we have to scan it for quality control, and afterwards we are scanning them again for this process of spraying concrete, for example, to figure out how the parts of the movement for the robot will be and so on. So this is we are collecting data all the way from the beginning to the end. So what we have in the end is, of course, it's a product, but also we have a twin model, virtual model of it. So the reason why we can use, in fact, Industry 4.0 technology here, especially IoT technology here, is because of this. This is decentralized, not hierarchical build production way, with always repeating, repeating parts of robot movement and so on. And in the next slide, I will show you how we are doing this. So what we see here is one production unit that is being surrounded by this dotted line. On the left side, we see an external parts, for example, data storage, phone generator. It can be also a CNC production unit. Inside of this dotted unit, we see several modules, and this is how, in fact, the system works in forms of modules that are connected with a very specific communication protocol. We use here MQTT communication protocol that is working with subscribing and publishing data. So there are some modules that is publishing data. For example, a robot is publishing its position or its state, and some other robots are reading then the state and position. This is very important because we have this is the possibility of these modules supporting each other. For example, we have during the spraying process. It can happen that sometimes spraying is not so clean, so after it's sprayed, the scanner will then check this sprayed area and analyze the thickness of the sprayed concrete. And if it figures out that this is too thin in this area, it will then again spray on this area. So this is an iterative process where it cannot be figured out in before, it has to be figured out during this process. And this is important that these modules, in fact, here we talk about robot controlling systems are talking to each other. On the other hand, we have also modules are very helpful because they can be exchanged quite quickly. It's very flexible to work with modules. They can operate in different operating systems with different complex and not so complex programming languages. So it is quite or much easier to work with in a modularized production system than in a hierarchically based system where an exchange of each part is very difficult, especially during when also production is already started. So here we see the result of the spraying. It's got two layers and some additional layers with corrections on these areas that have not been sprayed well. This can happen during the spraying process. It's a very thin module. It's very light. We can easily lift it with with two hands. And it's following the background. The back side is following, in fact, the main form of the mold. You can see it on the right side.
Next to our regular ultra performance concrete, we developed an ultra high performance concrete with Ilija. The interesting part of it is that there comes some thermal insulation effect. So the interesting part is now that we can shotcrete 2 or 3 centimeter thick facade panels with a really, really nice surface. And we can do that 3-dimensional, and at the same time, we don't only have an exposed facade panel like a general concrete facade panel. Here we have an insulated facade panel, and this is very interesting because of the thermal insulation of a complete building. The cyber-physical system allows us to produce intelligent facade elements, for instance. So we can use different kind of ultra-high performance concrete in different kind of layers. So we can easily adapt the thickness of a layer depending on the function of the facade. And we can produce insulating facade panels, but at the same time, or maybe as a different application, we can produce bulletproof facade panels. And that's very interesting with our technology, that the machines are able to produce with one system different kind of facade panels for different kind of applications.
So in this presentation, we showed you how sprayed concrete can be combined with cyber-physical system and how we can, in fact, build very precise and thin modules out of concrete. Also, Gregor presented you the prospect and further development of this system. And I hope that we have enough questions that we can maybe chat after this presentation. So looking forward for your questions. Thank you very much, and bye.